Hello everyone. In this lecture, we are going to discuss about parsing the input string CD for the same SLR parsing table. Okay, for this grammar. So here, first we need to construct the three columns stack input action, and initially we need to write the state 0. Okay, so first we have to write 0 on the stack. Input should be CD followed by dollar. Okay. Then we have to refer the action table. Okay. We need to refer the action table for a stack and input. Okay. The top of the stack is 0 and the current input symbol is C. It means that the left end of the string represents current input symbol. Okay. 0 and right end of the stack string represents top of the stack. Okay. So here 0 comma C. So 0 comma C means S3, right? So we have to write S3 means shift. So we need to write 0 here. We need to shift one input symbol uh, on the stack along with the 3. Okay. In 0 comma C, we have seen shift 3, no? Shift state 3. So 3 should also be shifted. Okay. In the shift reduce parsing, normally we will shift only one input onto the stack. But in SLR parsing, LR parsing and all, we have to shift the symbol as well as state number also. Okay. So C3. So C is shifted, no? So the remaining input is DCD dollar. It means that we are advancing the input pointer to the next input symbol. Okay. Now 3D. 3 comma D means shift 4. So we have to write shift here. So 0C3. We need to shift D as well as 4. Okay. 4. So we have shifted D, no? So the remaining input string is CD dollar. Okay, then 4 comma C. 4C means reduce by production number 3. Okay, so reduce action. So we need to write reduce by 4C means 3. So production number 3 means C tends to D. Reduce by C tends to D. Okay, whenever we are doing reduce action in shift reduce kind of parsing, we will replace the right side of the production by left hand side of the production. Okay. So, but here in LR parsing and all, we have to calculate length of the right hand side of the production. So here length of the right hand side is 1. Then multiply that number by 2. So 2 into 1 will be 2. Okay. So pop those many symbols from the stack. So two symbols must be popped from the stack. This is because whenever we are shifting input symbols from the input buffer to the stack, we are also shifting state numbers. Okay, so whenever we are popping the symbols, we need to pop um, two symbols. If you want to pop one symbol, we need to pop two symbols because state must also be popped. So first calculate length of the right hand side. It is 1. Then multiply it by 2. So 2. So pop two symbols from the stack. Okay. So top of the stack is right end of the string. So now 0C3. Pop these two symbols. Then push left hand side of the symbol. Okay. Capital letter C. Then we need to refer the go to table 3C. 3C means 6. Okay. So that should also be pushed onto the stack. Okay. So if you want to do the reduce action, first calculate length of the right hand side, multiply it by 2, then pop those many symbols from the stack. Then push the left hand side of the symbol as left hand side of the production as well as refer go to table for this 3 and C. Okay. These two symbols. So that is 6. That should be pushed onto the stack. Okay. Whenever you are doing reduce action, no change in no change in input buffer. Okay. Now 6 and C. 6 and C will be reduced by production number 2. Reduced by production number 2 is capital C tends to small c capital C. So capital C tends to small c capital C. So here length of the right hand side is 2. 2 symbols. So multiplied by 2 means 4. So pop 4 symbols from the stack. So now C3, capital C6, all 4 symbols will be popped. Then we have to push the capital C as well as 0, comma C. 0 and C is 2. Okay. And no change in stack. Sorry, no change in input buffer. Then 2 and C. 2 and C is S3. S3 means shift 3. So 0, C2, we need to shift one symbol. So C, then 3. Okay. So C is shifted, no? So the remaining symbols are D and dollar. Then 3 and D. 3D means shift 4. So right shift here. Here 0, variable C, 2, terminal C, 3, shift D as well as 4. Okay. Then 4 and D is shifted here. So the remaining symbol is dollar on the input buffer. Then 4 comma dollar. 4 comma dollar means reduced by production number 3. So write reduce by production number 3 means C tends to D. So reduce action means we have to calculate the length of the right hand side. It's 1 multiplied by 2. So 2. Pop 2 symbols from the stack. So 0, C, 2, small letter C, 3. These 2 symbols must be popped. Then we need to write capital letter C as well as 3, 3C. Go to table. Refer go to table. 3C is $6. Then 6 and dollar. 6 and dollar is reduced by production number 2. C tends to small c capital C. So reduce by C tends to small c capital C. So here length of the right hand side is 2. So pop 4 symbols from the stack. So C 0, C2. Pop C3, C6. Okay. Then we have to write capital letter C as well as 2C. 2C is 5. So write 5 here. Here no change. So dollar. Then 5 and dollar. 5 and dollar is R1. So reduce by production number 1. Reduce by R1. So S tends to CC. Okay. So here also length of the right hand side is 4. 2. Length of the right hand side is 2. If you multiply it by 2, we will get 4. So pop 4 symbols from the stack and then write left hand side of the production. So yes as well as 0 yes. 0 yes is 1. So 1. Then here dollar. Now 1 comma dollar. 1 comma dollar is accept. Okay. So the action is accept action. Okay. So in this example, we are getting shift, reduce and accept actions. Suppose the input string is wrong. Wrong means we will be getting error action. Okay. So here in action table, we will be end up with any of the blank cell. Okay. Then only we will write error action. Okay. So here we have parsed CD using SLR parsing method. Okay, so it builds the parse tree from bottom to top. Okay, so if you consider the CD string CD and try to construct the parse tree in bottom up fashion. If you consider the productions in order, C tends to D. So first, this D will be converted to capital letter C. Then small c, capital C will be reduced to um, capital letter C. Actually, this is small letter c. Okay. Small c and capital C is reduced to capital C. Then D is reduced to capital C. Then small c, capital C again reduced to capital C. Then these two C's are reduced to yes. Okay, so from the string, we are getting the start symbol of the grammar, or we can say that the parse tree is constructed from bottom to top. Okay. Now, if you consider the second input string CCD, uh, here also we will write 0 on stack, the start state 0 on stack, then string CCD dollar. Okay, now refer 0 comma C is shift 3. So shift is action 0. We have to write C here. Then 0 C. 0 C will be again. No, actually shift 3 means we have to write 3 here. Then we have already shifted C, no? So the remaining input is CD dollar. Then 3C. 3C means shift 3. So shift 0 C3, shift C as well as 3. Then remaining input D dollar. Then 3 and D. 3D means shift 4. So we need to write shift and 4. Okay. So we have to shift D, then write 4. So remaining input is dollar alone. Now 4 and dollar. 4 comma dollar means reduce by production number 3. Okay. Reduce by C tends to D. Reduce by C tends to D. So now the length of the right hand side is 1. So pop 2 symbols from the stack. So we have popped, we are going to pop D and 4, then right left hand side of the production C, then 3C. 3C means refer the go to table. So 6. Okay. Then dollar here. 6 and dollar. 6 and dollar means reduced by production number 2. So C tends to CC. Reduced by C tends to small c, capital C. So now length of the right hand side is 2. So pop 4 symbols from the stack. Okay. So C 0, C3. We need to pop these 4 symbols and we have to push C as well as 3 comma C will be 6. Here no change in input buffer. Then 6 and dollar. 6 and dollar is reduced by production number 2. So reduce by production number 2 means C tends to small c, capital C. So length of the right hand side is 2. So pop 4 symbols from the stack and then write the left hand side of the production. Then 0 C. 0 comma C is 2. Okay. Here no change in input string. So dollar. Now 2 comma dollar. Okay. 2 comma dollar is blank. Okay. So 2 comma dollar is blank means we need to write error action. Okay. Because this input string is a wrong input string. Okay. We cannot parse this input string for this grammar. Okay. This is the example for getting error action. Okay. Thank you.